2, 3, 4. Hey guys. Yeah, like my sister's Okay, so does anyone have any questions about the homework? Questions? So if you saw the email, Zoom doesn't want me to do classes over 40 minutes now. And since I'm starting a little early, then I'm expecting Zoom to kick us out sometime like 7:30, no 8:37 in my time. So Zoom, I expect Zoom to kick us out, and if they do, then just sign in again with the same code, and then we'll be back in. Okay. But yesterday during my physics class, Zoom didn't kick us out, so I think it glitched or something. So hopefully that's the same thing that's going to happen today as well. I see Gavin is doing a Rubik's Cube. Are you good?
Yeah.
I'm really bad at it. I've tried before, but I just never really gotten it.
Just Google how to do it.
No, I can't understand it. It's too complex. So I'm gonna ask this again. Does anyone have any questions about the homework? So for those of you that no questions? Okay, cool. I think we should have around 5 more people to come in. So let me. Oh, someone playing piano. Here we have the PowerPoint for this week. Here. So I'm gonna wait just a little more. As you can see, I've changed the theme of this PowerPoint. It's got oranges and the sun, I think. Okay. Who's that? Okay. So I'm gonna get started. So this week, what we're gonna talk about are decimals. Okay, I think a lot of you already know what decimals are, and we're gonna go over the basics of decimals along with some of the more advanced aspects of decimals. Okay. So the topics we're gonna discuss are, first of all, what are decimals? And I want to do arithmetic with decimals, which means multiplication, addition, subtraction, and division. And then we're going to do, we're going to practice changing decimals into fractions. Okay. And then we're going to be talking about repeating decimals. So first of all, what are decimals? My computer's glitching a little. So what are decimals? So we know decimals are some numbers like 39.2. Okay, so that's the most like really basic decimal. Okay, so these are decimals. So what if I had a more complex one like 9.263? Well, what are these places called? We know we have the ones place here, and we have a tens place here. What are these places called for the decimals? I think a lot of you know these already. This is called the tens place.
Hundreds, thousands.
Okay, so the places are just like a flip of the ones to the left of the decimal point, just with a THS at the end. Tenths, hundredths, thousandths. Okay. So what do these mean? Well, tenths means that this is a 2 times 1/10. That's the meaning of this digit, right? If we had some number like 39, we know that the first digit, it's not a 3, it's a 3 times 10. Right? And then the second digit is a 9 times 1. So the same thing goes for decimals. Okay, so the first digit is a 2 times 1/10. The second digit is 6 times 1, 100th. The third digit is 3 times 1, 1,000th. So these are why they're called tenths, hundredths, and thousandths. Okay? So we could write this decimal as a sum of all of these fractions here. But an easier way to write this is to write it as 9.263. This part is just 263 over 1,000. Okay, so this is the shortcut to finding it. This is 263 thousandths. Okay, does anyone have any questions about this? These are basically what decimals are. So we're going to go on with arithmetic with decimals. So what is arithmetic? Well, we're going to first look at addition and subtraction. And this is actually pretty easy. As long as we line up the decimals, for example, we had 39.2 again, and we wanted to add 6.34. We just need to line the places up, okay? We just line them up, and we add them, okay? Nothing too complicated here. And we just have the decimal down below. So if I were to do this, I would have 4, 5, 15, 4, okay? And the same thing goes with subtraction. How do I multiply? Well, if I had something like, let's say 1.6 times 1.2, well, how do I multiply these? Well, the cool thing here is that I can just ignore the decimal point at first. It will just be 16 times 12. I'll just do this normally. 3, and then I'll have a 6 and a 1, 2, 9, 1. Yeah, just basic multiplication here. But clearly our answer is not 192, right? Both of these numbers are just a teeny tiny bit greater than 1. So the answer is definitely not 192. So how do I know what the answer is? Well, the trick here is to count the number of digits to the right of the decimal point in both numbers, okay? So for example, we have one digit here and another digit here. We have 2 in total, okay? So that means in our answer, there must be 2 digits to the right of the decimal place as well. So we're going to put the 2 and the 9, 1.92. Okay, does everyone get that? So that's how you would multiply decimals. Okay, so first of all, you ignore the decimal point, just multiply it normally, and then you count the numbers to the right of the decimal point in both of the numbers that are multiplying, and then that is the number of digits that is supposed to be to the right in the final answer. So how do I divide decimals? Okay, we're going to have something like, I don't know, 4.9 divided by 0.07. Well, what I can do here is that I can multiply both of these by 100 and turn both of these into integers, into regular numbers. Well, how does this work? Well, I just multiplied everything by 100. Shouldn't it actually change the problem in some way? But we should remember that division is just a fraction. And if I multiply 100 on the top and the bottom, these will cancel in the end, and that doesn't change our final answer. So when I multiply this by 100, 4.9 turns into 490, and that's being divided by 7. So now we just have a really simple regular division problem, and we can just do this straight off the bat. This will be 70, and yeah, that is it. okay? And our answer will be like this, okay? So that's how you would do arithmetic with decimals. Let's get on to a few problems here. So I'll give you guys, whoa, calm down in the chat.
Guy, I don't like using that calculator.
Yeah, if you're doing this, if you were to use a calculator, then you would just have the answer, I guess, right?
Yeah, it looks right.
So if I don't reply to all of them, yeah, that's because there are a lot of people responding. So if I don't reply, then we should be good. Someone's playing piano. Let me see.
Even more accurate. Entire day. Let's see. Right? Let's update.
The first position.
How do you cope
Push
with
the
COVID?
floor away. And we want to do that in 4 beats.
So who's the one taking a piano lesson right now? I think someone's taking a piano lesson. Okay, so since I have a lot of people answering already, I'm gonna go through now. Okay, so for the first one, this is just simple addition, right? We just need to line these numbers up. So 8.9 and 2.94, make sure they're lined up. And now we just add 4, 8, put a 1 up there, 11.84. I think that's right. Wait, let me see. I can't see my problem here. Okay. So for the second one, again, very simple subtraction. Just line these up. And for me, I don't really like seeing a blank space there, so that we can just put a 0 there instead. So we just do the subtraction. 5.96. Okay. So now for the multiplication, what we can do is we can ignore the decimal point at first. 8. So instead of writing 8.9, we can just write 89 times 294. And for me, I like to see the top one, the bigger number on the top. So I'll just rewrite this a little bit. That's just my own little habit. So I'll just multiply these out normally. 36, 81, 84, I think. And then 18, 26. 2, 3. This is 9 times 8, 72, plus 3, 75. 2 times 8, 16, plus 7, 23. 6, 6, 1, 6, 2. Okay? But clearly our answer is not 26166, 26,166. So now we need to count the numbers to the right of the decimal point. So if 1, 2, 3, so we need to have 3 in our final answer as well. So that will be it, 26.1. Okay? So now we have the division problem. I don't like to look at these as decimals, so I can turn them into integers. If I multiply both sides by 100, it will turn them into 360 and 9. This will just be some simple division. Okay? Any questions? Okay, so Felix is having the piano lesson. Someone is playing piano. I think they've stopped now. Okay. So now we're going to talk about decimals to fractions. All right? So what if I gave you some kind of decimal here, 0.29? How do I turn this into a fraction? Well, this is just 29 hundredths. 29 over 100. And that's it. Right? That's basically how you would turn this decimal into a fraction. You would just take the number here, okay? So you just take the number and put it under some kind of power of 10, depending on how large this number is. In other words, if we would have something like 504, this is 504 over, not 100, because if we were to divide this right now, this would be 500 over 100, that would be some number around 5. So we need to add another 0, 504 over 1,000. Okay, so this is basically how you would turn decimals into fractions. Okay, but what if I didn't have something like that? What if I had something like, I don't know, 2 over 25? Well, now I can't just turn this into, I can't just take this and make it like 0.2 or something, right? So the first method for finding a decimal like this, I can just divide it up, right? Fractions are division problems. 2 divided by 25, I can put a lot of zeros at the end. And I'll just divide this, right? And that'll get me to the answer. But a better way to do this is to see how if I turned 25 and then multiplied it by 4, that would turn 25 into 100, right? And once I have 100, whatever number up here, I'll just turn it straight into a decimal. Okay, so since I've multiplied by 4 on the bottom, I'll multiply by 4 on the top as well. So I'll have 8 over 100. That's just 0.08. Okay? So if you see a fraction like this and you want to turn it into a decimal, what you want to do is you want to look for ways to turn the denominator into a power of 10, like 100, or maybe 10, or maybe 1,000. Okay? Jamie raised her hand. Do you have a problem?
What if the number at the denominator isn't able to multiply into 100?
Okay. Yeah. If it's not, then what you can do is you just have to divide it out. Like if you were to have, I don't know, 2 over 21, for example, you just have to divide it out. There's no other way to do it. Okay? But normally, tests are not going to give you questions like that. Okay? So let's convert these numbers in these problems. So I'll give you guys maybe 2 minutes. Okay, I'm going to go through these problems now. So for the first one, this is just 23 hundredths. 23 over 100. Okay? So another way to look at this is you can see how this is, the 2 is in the tens place. This is a 2 times 1/10. Then we're adding that to a 3 times 1/100th. And now we can just add these two fractions by making a common denominator. If I multiply this one by 10 on both sides, I'll have 20 over 100 plus 3 over 100, also 23 over 100. But a more direct way is just to go ahead and do, just to look at it and say 23 hundredths. All right, and similarly for this one, we can just write this out, 2939. Okay, but be careful here. If this number was just a little bit bigger, with let's say an extra 0 at the end, then this number would not be 0.2939. It would be 0.02939. Okay, so you got to be careful in how many zeros this number has. And the trick here is to look at the number of zeros in here. We have 4 zeros, right? And we have 4 digits in the number. So if we have the same number of zeros as in digits, then we don't need to write any extra zeros. All right? So if we had, say, like, I don't know, 5 zeros here, then we would have to add an extra 0 at the end, okay, in the beginning. All right? Does everyone understand that? So be really careful when you look at these numbers, okay? So you got to count how many zeros there are, and then make sure that you understand that whether or not there's a 0 at the beginning. Okay, and for the last one, I could divide it out. I could, but I really don't want to do this, right? It seems like it will take a million years. So what I can do is I can see how I can see how 250 times 4 will get me to 1,000, right? So if I multiply 4 on both sides of this fraction, I'll get 39 times 4 over 1,000. And then when I get 39 times 4, I'll just put this in as a decimal, straight ahead. So this multiplication is not that hard. 39 times 4, 15, 156. So this is just 156 over 1,000. And just to make sure, I have 3 zeros on the bottom, 3 zeros, 3 digits on the top. I don't need to add any extra zeros. 0.156. And that is the answer. Okay? So as you can see, it was a lot easier to solve if I went ahead and realized that 250 times 4 equals 1,000, right? If I were to try to divide this out, then that would take a very long time. Even if you're really good at dividing, I guess that would take quite a long time. Okay, so now we're going to talk about repeating decimals. And when we think of repeating decimals, the most common one that comes to head is 1/3, right? 1/3, as we know, is 0.3333 forever as a decimal. All right, and another way to write this is a 0.3 with a line on the top. So what does this line mean? This line basically means that we're going to go on repeating these 3's forever. Okay, if we had 2 numbers under this line, then we would be repeating both of these numbers forever. Okay, something like that. Okay, so what if I had something like 0.1 repeated? Well, a way to solve this, how do I turn this into a fraction? Well, let me set this number as x, okay? I'll just call this x. Okay, then 10 times x, well, what does multiplying by 10 mean? That means moving the decimal point to the right by 1 place. 1.1 repeated, right? Does everyone see that happening? So in the beginning, we had 0.111111, and then we just took the decimal point and plotted it right there, okay? We still have infinite ones at the end. So 10 times x equals 1.1111. But as you can see here, this is x, right? So we have a 1 adding to x. So 10 times x equals 1 plus x. So now we just have an equation that we need to solve. I'll take the x's and I'll put them on the same side. 9x equals 1. Divide by 9. X equals 1/9. Okay? And the cool thing here is that if I had something like 0.3 repeated, that's just 3 nines. 0.5 repeated, 5 nines. So any number with one digit repeating forever, that will have a denominator of 9. Okay? What if I had two digits repeating forever? Something like 0.01 repeating. That would be 0.010101. What would this be as a fraction? Well, if we set this as x again, right? I can multiply this by 100 to get 100x. Well, what does multiplying by 100 mean? That means moving the decimal point 2 places to the right. So then what do I have here? I have a 1.0101. And just like the first example, this is x. This is 1 plus x. 1 plus x is 100x. Getting the x's on the same side, we get 99x equals 1. Dividing by 99, x equals 199th. All right? And the cool thing here is that if I had any number, 2, 3, repeating forever, we can just put 2, 3, and bam, put it under a 99. And that will be the fractional form of this number. So this is a really, really important trick that you should remember, okay? So for any number xy, these two digits repeating forever, so this number would basically look like xy, 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 da 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 da. This would just be xy over 99. Okay? What if I had three digits repeating forever? 0.001 repeating. So this would be 0.001, 001. Oops, one too many zeros. Right? What would this number be? Well, if we set this as x, once again, if we multiply this by 1000x, that means moving the decimal point 3 spaces to the right, which means we're going to have 1.0010001. And as you can see here, we have x again. 1 plus x equals 1000x. Subtracting on both sides, 999x equals 1. X equals 1/999. Okay, and just like with the previous two examples, if we had any three numbers being repeated forever, this would be those three numbers. Bam, under a 99, and we're done. Okay, so this is an important thing to remember. So as you can see here, if we had two numbers, it would be under 99. If we had just one number, that would be 9. So what if we had four numbers? Well, based on logic, we're just going to have 9999, right? So that means that 0.5454 repeating forever. Maybe I'll do 0.5 like this, repeating forever. That's 5452 over 4 nines. Okay, so this pattern is going to go on forever for however which many numbers you're repeating. Okay, does everyone understand how this trick works?
Yeah.
So to recap, if we had one digit repeating forever, that's going to be that digit over 9. If we had two digits repeating forever, it's those two digits over 99. 3 digits, 999. 4 digits, 9999. And if we had 5 digits, we would have 99,999. Okay? So that's only for repeating decimals. So if these numbers weren't repeating, if it was just 0.232, just like that, that's going to be 0.3232 over 1,000, okay? So be careful. This only applies to repeating decimals, okay? So here are questions. Let me write this line above the 39. So a common mistake I'm seeing on a lot of these is that you guys are forgetting to simplify these. Remember to simplify. Always remember to simplify. I remember back when I was in 5th grade, 6th grade, I would always forget to simplify and I would always get those questions wrong. Okay, so I'm going to give you guys maybe 1 more minute. Okay, so I'm going to go through these problems now. So for the first one, we remember our rule for repeating decimals, right? We'll just take this, smack it under 99, and it seems like we're done, right? But remember, we need to simplify. So we can cancel the 3 on both ends. 13 over 33. Okay, so this is the answer. So what about the second one? So the hint is don't divide it out. 33, as we know, 33 times 3 will get us to 99, right? So if we can get this fraction to have a denominator of 99, we can just put that smack under the line right here, right? So this is the same thing as multiplying 3 on the top and bottom. So this is just 29 times 3 over 99. So let me just do 29 times 3 right here. 7, 2, 8. 87 over 99. So what is this as a decimal? 0.87 repeated forever. Okay? And the same thing goes with this one, 1 over 11. 11 times 9 is 99. So we're going to multiply the top and the bottom by that. So we have 9 over 99. So a lot of people said 0.9 repeated. Well, what is 0.9 repeated? It's just this, right? But isn't this equal to 1? At least it's really, really far away from 111. So this is a really, really careful thing you have to do here. It's 0.9 repeated only if it's 9. Oops, what did I just do here? If it's 9 over 9, right? Because if we have one digit repeating forever, it has to have a denominator of 9. So what is this actually? Well, 9 is just 0.9, right? With 2 digits. So this is just 0.09 repeated forever. Okay, so you guys got to be really careful there in terms of that problem. Does anyone have any questions about this? Alrighty, it's quizzes time. So I'm gonna stop sharing. Let me see if I can get my quizzes going here. Okay, so I'm gonna play this live. All right, let me share my screen now. Go on to the quizzes. So the code is up.
Can you give the link?
Okay, so the direct link. Okay, I'll copy this link.
Thank you.
My computer is messing up. Dang it. Okay, here it is. Let me chat this to everyone. The direct link is right there. Or you can go to joinmyquiz.com with the code 709604. So can everyone see my screen right here? Gavin the Cuber. Wow, that's nice. I think I should have 35 at the end, or maybe something close to that. "21 participants in the quizzes." So I think last time our first place winner was Brendan, something like that. And Jonathan, I think Jonathan was one of the top 3 as well. So let's see if they can do it again this time, or if someone else is going to take the top standing. So I'm going to wait one more minute for you guys to come in, and then I'm just going to start the game. So there is a random trivia question that I put in this quiz. So let's see if you get that trivia question correct. All right, I'm just going to start the game now. Ready, set, go. Brendan in first place, just like last week, I think. Whoa, we have 4 people with perfect streaks of 3. So that would be Ryan, Ella, Adolf, and Serena. So Andrew is currently in first place with 7 correct answers. Right now in first place, Ryan has moved to first place, with Andrew in second. Seems like Ryan's gonna end in first place. Helena up in second place now. Ooh, Andrew. Take a look at the questions. This is the random tribute fact right here. A snail.
The snails one really.
So Ryan is
chaotic,
currently in
just like
first place. Helena in second. Ellie in third. So it seems like most people are finishing up now. Let's see if someone can get to the top. Richard, coming from nowhere, is number 9 right now with only 1 incorrect, I think. So I'm gonna keep this game going for about 1 more minute, and then we'll see who will be top standings. Alright, I'm gonna end the game in 3, 2, 1. So who are our winners? Third place, Ellie. Second place, Helena. And then first place, Ryan. Nice job. So, I'm gonna unshare. So that will be the end of class today. Hope you guys enjoyed. And I'll see you guys next time. Bye.
Bye.
Bye. See you next time.